Okay, so today we're going to be looking at categorical variables and how they work in regression. And we're going to be replicating the lab that we did in SPSS and R in today's video. So let's get started. First thing we always have to do, well, let me clear my workspace. You see my environment's empty. So when I import my data set, you'll see right there, it pops in the environment, 51 rows of data, 9 columns of data. As usual, you can click on it, see a nice little data set there. Now, the first thing we did in the lab is we actually looked at exploring the data visually. So our DV is continuous, right? SAT verbal scores. And now we're looking at categorical variables or grouping IVs, independent variables. And specifically, we'll be looking at the area variable. So I think the best way to explore a continuous DV in categorical IV is box plots. And before we get there, we need to know how R actually saves categorical variables. So there's really two ways that R can do this. One, so area, if you click in there, you see it's a vector. There's many values, 51 values or elements, and they have quotes around them. So that makes area a character vector. And of course, as usual, we can use the class argument, the class function with that $area as the argument or input to the function, and it will tell us it's a character vector. Now I can make tables, so you can see I have 10 Midwest, etc., etc. So, but there's another way that R also handles categorical variables, and as we'll see later in this video, this is usually more convenient in regression, and that is factor. So here, what I'm doing is there's a function called factor, and I'm just wrapping the character vector area right inside that factor. And I'm going to name it area underscore factor. So let me do that. So, it doesn't change the underlying data. You see when this should be area factor. It's the same data as before. The only difference is if you look at the class, it's now a factor of 4 levels. And I can also cross-tabulate it. So look here, I've cross-tabulated area. You can do the character or the factor, it doesn't matter now. You can cross-tabulate it and you can, like, for example, the West includes the mountain region, the mountain area, the Pacific area. I'm not sure what WNC stands for, West, North Coast, maybe, I don't know. In any case, you can cross-tabulate it and compare two categorical variables by just wrapping them both in a table function. So I do that a lot. It's pretty helpful. Now, getting back to the box plot, we can use base R. And so base R is really, really simple syntax, just a box plot function. You put the DV here on the left. I shouldn't say DV, it could also just be a continuous variable. It doesn't have to be the DV. Normally, our y-axis does have the DV though. And so you can see the spread of SAT verbal scores, and then we're going to chunk that out into the different regions. So you can see there's clear variation in SAT verbal scores across the different regions. Northeast very low, Southeast has a huge spread, where the Midwest has a moderate spread, but is in general a lot higher than the others. You can see the median is significantly greater than the other medians. Even the 75th percentiles or third quartiles, the median here is higher. So it clearly seems that SAT scores vary according to region or area. Now, we can also use ggplot to make pretty graphics. So, this can make journal ready graphics. And I'm just showing you kind of like the simplest way to do this. If you go on Google, there is so much support because ggplot has such a huge user base. You can really make this do whatever you want. Anything you can dream of, you can do. The cool thing about it is you can also save your figures pretty easily. So I named this ggplot. This creates the plot. I named it in an object called plot. So you'll see plot is this kind of complex object which R calls a list. A list is kind of like a combination of many different data elements. And the plot argument in the ggsave function, if I had named this plot 1, then basically I'm telling ggSave that, hey, the plot, well, its name, the thing that I'm trying to save is called plot1. And then you give it a name. Now look, for this name, I have put the word figures / here in the file path. So what that does, you need to create a figures folder on your computer. So let me show you. This is where I have my regression R lab saved. If I go into figures, you'll see it's blank. And you can also see it, of course, in the R Studio bottom right pane for the files. Now, like if I save this and I've given it a height, width, DPI, I think that's dot per inch, and then I want to save it as a JPEG. Notice how I gave it a JPEG extension. There's other kinds of file formats. You just go on, again, so much support for ggSave and ggplot in general. You can just Google and find what you need really quickly. So I click into the figures and it tells me, you know, March 19th, I just created this box plot. I go back to my computer and yeah, there it is. Just going to open it up just like that. You can copy and paste that, import that into your document. So, you know, I really like this ggSave. It's really a good 1-2 punch for exporting images that you want to create in R into whatever PowerPoint or document you are working on. Okay, so that's data exploration, how we can compare a continuous DV to a categorical IV. Now, what about recoding? So how do you recode a variable? How do you create dummies? We're going to do these two things next. And there are packages that you can find online. I found them easy to use at time. Again, you just Google that. I prefer to use the if else function. It's a very, very powerful function. You want to get really comfortable with it. So when you're learning a function, let's see, what is this? I guess I clicked on the wrong thing there. So, you know, you can always question mark and then write the name of the function. And it will come up and tell you basically what it is. And you'll see that there is three main arguments. One is a test. So that's going to return a true or false statement. If it's true, it's going to do something. And if it's false, it'll do something. So the first argument is what it does when it's true, when it evaluates to yes. And the third argument is what it evaluates to when it's false. So let's look at the area variable. There are 4 different categories of the area variable, right? So if I have 4 categories or levels, I need 4 dummy variables, right, to completely represent that. Now, how can I make those? I can use the if else function. So the first is just a logical test. So what I'm saying here, you know, notice the equals equals. So when you do logical comparisons in R, it's like, you know, you can do equals equals, you can do greater than or equal. What is it? I can't remember if it's like this or this. You just have to explore. I'm pretty sure it comes second. But in any case, we're going to do equals. So if you just do a normal equal sign, it will not evaluate, because the normal equal sign is not, it doesn't mean anything for R. So you see, I don't even, oh, it overwrote area and set it to northeast. So if I was to actually, see, that was a mistake. They're all going to be northeast now. So let me go re-import my data. And what I want to do though is I want the logical comparison. So this is going to return a vector of trues and falses, because it's basically just saying, when does area actually equal northeast? And that should be true exactly 12 times. Now that's the first part of the if else statement. The second one is what to do when it's true. Well, when it's northeast, let's make it a 1, or it's 0 when false. And I'm going to name it area underscore northeast. So you see, pretty easy to use the if else statement, very powerful. Now I'm going to look at just a subset of the new data columns I created. So when area is southeast, that dummy is a 1, everything else is 0. So this is what dummy variable should look like, right? A bunch of zeros, and then there's across the 4 levels, only one of the columns, they're mutually exclusive, can take a value of 1. And as always, we're going to cross-tabulate and check. So we're going to compare the original area variable to area northeast. When area northeast is 1, the original area variable is northeast. And going through that, always check your data. It's really, really important. Okay, so that's how we that's how we create dummy variables. Also a type of recoding. But secondly, let's say I have a variable like region, which has 9 categories. I want to turn it into a categorical variable that has fewer categories by grouping some of these. Well, I can do that pretty easily, kind of using nested if statements. So look, we have an if else statement here. And how you read functions in R is you kind of want to evaluate on the inside first. So here what I'm doing, I'm using the if else statement. And what I'm saying is if this is a data vector, right? Dat.region, you see it's got 9 values. If one of the values, this %n%, this is a special operator that says, hey, when element 1 is in this list, MA or NE, then it's true. And then it goes to element 2. When NE is in MA or NE, then that would be true. So you can see the first one should be false. The second one should be true because we see that the second element is NE and the second element of region is NE. And that's what we're asking it. We're asking it to compare these two elements, these two values. What element in region is in this list? And if it's in NE or MA, then I'm going to return true. What do I do when it's false? Well, I'm going to go ahead and run another if else statement. And this time I want to check if it's in WNC or ENC. And if it turns out to be in one of those values, well, then that's true. I'm going to return a Midwest. And then I'm going to keep going. Let's say that the value in region is actually, it's not in Northeast, it's not in Midwest, so it's false, false. So it comes down, it's the third argument in the if else statement is what to do when it's false. Well, I'm going to run another if else comparison. And this time, if it's in ESC, WSC, or SA, I code it as south. Otherwise, I'm going to let it be west. And I'm going to wrap all that in the factor function because I want to make it a factor, not a character vector. So I run that. I named it area 1. Notice it's a factor of 4 levels. And then I can test it, and basically make sure that what I intended actually happened with the recoding. So there we move from 9 categories to 4 categories. Okay. Now, how do we make a continuous variable a categorical variable? That's called categorizing or binning the variable. I think a pretty good place to start is using the median, because the median is the value in the data that splits the upper 50 from the bottom 50 percentile, right? And so look, I'm going to create a new variable. It's going to be called teacher pay binary. I'm going to make this a factor. I always want to make it a factor. You'll see why in a little bit. I'm going to use the if else statement again. This time I'm going to compare teacher pay. Is it less than the median? And look, let's see, earlier I didn't talk about it. Is it less than equals? Yes, it is. So, you can play around with that. You can see the logical operators in R, you have to have a greater than or equal to operator. And that's why R strings two equal signs together to make these logical operators, because you have to have that for greater than or equals to. Here, I'm just going to do less than, it's just a demonstration, so it doesn't matter. And look, when teacher pay is less than the median of teacher pay, I'm going to go ahead and say, well, you're just low teacher pay. And if you're not less than the median, you're going to be greater than the median, and I'll call that high teacher pay. So I create a new factor variable that has 2 levels, high and low teacher pay. And now I can cross tabulate the original teacher pay with my binary version. And you can see, it's going to order teacher pay here for me. And it's low, low, low until it crosses that median threshold, and then it's going to be high, high, high. Now, I only have 51 data values, so it's possible to cross tabulate it like that. So if you have a lot of data, this may be kind of not a good way to check your coding. because there's just going to be like way too many rows of data. Like if there's thousands of different values for teacher pay, this would be crazy. But with 51 variables or values, I mean, we can get there just fine like this, the data check. Otherwise, you might kind of eyeball it. Okay. Now I have other options for binning a categorical variable. So let me run summary on teacher pay. It gives me the first quartile, the second quartile, which is the median, and then also the third quartile. And so the first quartile, that's the value that splits off 25% of the data. So 25% of the states have less than the 31.55 scores. 50% are less than 35. And finally, 75% are less than 40.05, the third quartile. So I can actually use these and make kind of quartile, split it into 4 categories, right? And how do I do that? Well, it's the FLs function again. Here I'm doing less than the first quartile. Now in the second one, I have to do a compound condition because it needs to be greater than the first quartile, but less than or equal to the second quartile. And so go through those, then you're going to check it again. So here I'm checking the first quartile, and 31.6, it flips to zeros from there on out. I can check the second quartile. So you see it starts at zeros, then it's on for a little bit, and then it's all zeros again. So that's how you can bin continuous variables into categorical variables. Now there are 4 categorical variables we made, or dummy variables we made for teacher pay. You know that across all of them, they should sum to 1 because you have to be in Q1 area, the Q2 area, the Q3 area, or the Q4 area, right? And so if there's 51 people and they each have 1, you should get a 51 sum. So, another way to check this kind of stuff there. Okay, how do I actually add categorical predictors now? Well, the first way is to use the dummy variables, and we created dummy variables above, so we can call them back here. And notice I've left out Northeast, so that is going to be the reference category. So let me estimate the model. Notice how the Northeast is not in there. Now, a second way to do this is to just use the original character variable or the factor variable. So area, I want you to remind you, it's a character vector. R does allow you to do this, but I don't recommend it because it's going to choose a reference category at random. So that's why you use the factor version, and we created area underscore factor. And so look, if I call levels, the first category there is the reference category. So if I fit a model, Midwest will be left out. And you can see that's exactly what happened. Now I can relevel this or choose a new reference category. So there's a relevel function, and I'm just going to pass in the old factor variable, and I just want to change the reference category to the Northeast. And I'm going to overwrite that column by saving it as the same variable name. So I do this. I run the levels function, and now it's telling me, hey, Northeast has been set to the reference. So when I estimate a regression model, Northeast becomes the reference or omitted category. Now remember, each of these coefficient estimates tells you whether the difference between Midwest and Northeast in terms of SAT verbal scores is statistically different from one another. So it's a pairwise difference. It does not tell you whether the categorical variable of area matters. So to test that, we need the incremental test, because that comes down, we've got 3 coefficients for that one categorical factor. So we really need to do a simultaneous testing of all of those slope estimates at once. How do we do that? Well, we use an incremental F test, and in R, it's pretty easy. I create a model 0 where I have only teacher pay, and then I'm going to compare a model that has the full area factor added. I'm going to store them in 2 objects, mod 0, mod 1, and then I just call ANOVA. And it's going to tell me for model 2, it explains a significant amount of additional variation in the DV. In other words, the categorical predictor is significant. Okay, so that's all for this week's R lesson.